Hello everyone, this is Captain Gilbert Lee. Today we are looking into an incident week. This is motor vessel Sanchi, total loss with 32 lives lost. So the reasonable cause of this accident should be fully investigated. And also, how can we prevent it happen once again? What kind of practice was missing in the routine job of the navigational watch should be carefully studied. Okay, this is AIS track of two vessels. Motor vessel Sanchi was on the coast about 355 degrees, and the CF Crystal was on the coast of 217 degrees when two vessels meet each other. The speed of the Sanchi is color red, is about 10.5 knots, and in the blue color is Crystal, CF Crystal. His speed is 13.5 knots. So Crystal have more speed than the Sanchi. So okay, the principle of the collision avoidance is very simple. Two vessels have no significant bearing change. True bearing change may pose the risk of collision, but the actual technique need more consideration or more practice, more thorough understanding how to apply this simple rule to avoid the collision. We usually use the visual bearing to assess the collision risk. How about in a radar picture? What means we can be used to assess the collision risk? Shall we remember the true bearings reading? Like this, in this case, is how much degree? Measured with electric bearing line, which was called the EBL line. Like this in color purples, we set on the Taki CF crystal. The reading is about 0 to 2 as we read out from the compass reading around the radar picture. The true bearing is 0 to 2. The problem here is we always overflow with all this digital. So we don't need to remember this reading of 0 to 2 degree. We can leave the EBL line on the screen and touch it. Later, we check on the target's movement along this true bearing line. Also, we put another line in color light yellow to represent the small vessel, which was the concern of the third man. This light yellow electric bearing line have the true bearing about 0.35 degree. We can use these two true bearing lines to verify the collision risk with on-ship by leaving these two lines on the screen. don't need to read the true bearings digital number 022 or 035. These two EBL lines on the radar screen we didn't move in, and later we checked does the target coming along this true bearing, then there will be a collision risk. But if we need to use the EBLI for fixed ship position or measuring another vessel's bearing, then there will be a problem. Especially you are a seaman, and the captain is the one really using the radar. So you need another technique to remember how these two targets relative bearing or the true bearing is. So we have put the extension of the EBL line into the data area and use the crayon's mark pen to mark a yellow cross on the data area. Then we are free with this EBL usage. Remember what we are doing here. We mark the target bearing. First is by EBL. Second, if you can read the EBL bearing by the digital, but it's a waste. So we just take our yellow crayon pen and mark on the radar screen. Put a cross mark on the data area for later use. If you are a senior master, you must be thinking this is like a kindergarten's technique. But every little thing makes big difference. Especially it comes to the lookout. Someday this will cost your life to learn these lessons. So be careful on the detail. Everything can help you, but your pride cannot help you. Okay, let's check on the data area. There was some wrong setting. As you can see, the trail, which means the target's past position, live on the radar screen, the trail. Right now, setting is true trail, which means the tail or the trail is this target's true motion, not relative motion. This true motion sometimes can cause a lot of confusion, like this one. The true trail of the Taki CF crystal look like not came passing on ship's bow, but actually it's always there because its compass bearing or relative bearing never changed. So this true trail need to set to relative trail, and the time interval need to longer, so we can make more correct estimation of the collision risk. 6 minutes, 9 minutes should be okay. The second one is the vector of target and the on-ship speed vector. Here is 9 minutes. Situation like this, only 4-5 target on our starboard side. 9 minutes is okay. But if you remember what we were teaching in the radar lookout, in the dense traffic, this only needs 3 minutes to give more accurate collision risk estimation. Okay, we take one more look of the picture, then we move into next talk. Okay, let's check on this picture. Right now on ship starboard side there were 7 vessels. 5 vessels going to the direction 270. Look like approaching the Shanghai waterway. And these only 2 crossing vessels in our screen seems follow the original true bearing line. That means these 2 vessels have the collision risk at the same time. Only thing is, one vessel is big vessel, another may be a small vessel, and the speed look like not so much difference. Okay, so why the third may mistaken the big vessel as a small vessel? We can check on his radar setting. This is Sanchi's radar setting. We can see from the upper left, the gain is setting to 67, is not so strong. But the C cluster manually setting to 40%. So maybe this is reducing the target strength. As we say, the target identification is an important technique. The big vessel and the small vessel have only one means to distinguish from the radar screen, because right now the radars have not showing what is a big vessel, what is a small vessel on the radar screen. This is a waste, because right now the digital computer is very powerful. We can decide by the radar's detector bearing, detector range, and the echo strength to make the judgment by computer which was a longer vessel or a small vessel. And right now we have to use our own judgment with the menu control to switch the gain to the minima and leave only the stronger target on the radar screen to verify which is a big vessel and which is a small vessel. Okay, right now we reduce the gain from 67 to 40%. So hope we can reduce all the target, but only the stronger echoes target. That means bigger vessels remain on the screen. So in this way, we reduce the targets number from 9 targets to only 2 targets on the screen. So this 2 targets must be the strongest echoes target at the ship. So it means these 2 are bigger vessels. Usually, this job will doing by 2 radar settings, and preferred by the S-band, because 10 cm radar wavelengths give more stronger echo for big vessel and small vessel. So one radar is dedicated to detect the big vessel like these 2, and we use APA to auto-acquire these 2 targets to give us the collision warning. Another was setting for small range, for better in 6 mile or 3 miles range. to detect the small target, like fishing vessel or buoys at the sea. So prefer in the dense traffic, use 2 radar to distinguish large vessel or small vessel. If we use only 1 radar, then we are going back this confusing picture as before. So for small target, we use smaller range to reduce the target's number. But for the big vessel with faster speed, we prefer with longer range with S-band radar, so we can get more target echoes difference between the big vessel and the small vessel in radar's S-band radar. So we are finished our talk here. See you on next talk.